Thank you. So, as a group, developers, data scientists, technologists, well, we tend to think far more about the future than the past, unless that is we're obsessing about retro video games. The nature of what we do means that we obsess about now and next, rather than trying to put things into their historical context, and that's a mistake. So every once in a while, it's good to take a step back and look at history, and decide whether we want to repeat all our mistakes and our triumphs one more time, or whether we should be doing something different this time around. Because we've been here before, in 2011. 2011 was, by any measure, the dawn of the big data era. Because back in 2011, there were new tools appearing, new levers to move the world. We all got a bit excited. I talked at the first ever Strata, which not coincidentally was also in 2011. Except I didn't talk about big data because we weren't entirely sure what it was yet. I talked instead about machine learning. Nobody was all that excited about machine learning, which is funny how things turn out, really. The next year, I keynoted the first ever Strata in London. I didn't talk about big data then either. Instead, I talked about small data. And 8 years later, it turns out that small data systems might just be on the verge of taking over. But more about that in a bit, once it's obvious why that's happening. Because let's be totally honest with ourselves. As an industry, we have failed to bring people along with us. We have engineered increasingly intricate data collection, storage, and correlation systems. We have lakes, we have silos, and it doesn't matter. Because outside of this room, this conference, and this industry, our industry, the big data industry, is universally viewed as a dumpster fire. A McKinsey survey earlier this year asked CXO-level executives if their company had achieved any positive return from their big data projects. Just 7% answered yes. Last year, a similar survey was done by Gartner, who asked the same question. They got a 15% yes. So things are actually getting worse. And this isn't actually the real problem with the big data industry. More than a few years ago now, Mark Zuckerberg famously stated that privacy should no longer be considered a social norm. Zuckerberg was right, and it has been the mantra of the big data era. But I think there's a serious privacy backlash coming. I really don't think that the current age where privacy can no longer be assumed, that it's not a social norm, is going to survive machine learning or the Internet of Things. So let's take a real step back. A lot of the problems we're seeing with the Internet today are due to how the Internet was built. The arrival of a new application, a new service that broke some of the expectations of the people that wrote the standards and protocols that it's been built on. Well, not exactly new. New application arrived 26 years ago now. Because it was actually 26 years since the birth of the web. And that changed the Internet forever. I still rather vividly remember standing in a very drafty computing lab with half a dozen other people crowded around a Sun Spark station, looking over the shoulder of someone who downloaded via some torturous process the very first public build of Nazca Mosaic. I remember shaking my head and saying, "It'll never catch on. Who wants images?" Which shows perhaps you shouldn't listen to a word I say. But the arrival of the web broke the Internet that sits underneath it, because there really is only one business model on the web, and that's advertising. People have consistently refused to pay and subscribe for services or pay for content. Instead, advertising supports the services that sit underneath almost everything we do on the modern web. And behind advertising is, of course, the data that makes it possible, the data that makes it targeted, the data that makes people pay to actually advertise. Think how your day-to-day experience of the web would be different if Google charged a monthly subscription fee. You wouldn't be spell-checking your words in Google anymore, or doing addition. Or did a microservices-based approach to pay on a search-by-search basis. A series of almost accidental decisions and circumstances have led to a world where most things on the web appear to be free. Doesn't mean they are free, just that we pay for them in other ways. Our data and our attention are the currency we use to pay for Google for our searches and Facebook for keeping in touch with our friends. Whether you view that as a problem is a personal choice. But it was perhaps not unanticipated. With no idea of the web, which was still decades in the future, the people building the internet, the ARPANET, did think about the possibility. This from Alan Kay in 1972, who anticipated the black rectangle of glass and brushed aluminium that lives in all our pockets today, and the ubiquity of the ad blocking software that we need to make the mobile web even a little bit usable. If you have time, I heartily recommend tracking down Kay's writing. There really is a lot of value there. And while Alan Kay's prediction of the existence of the smartphone was almost prophetic, it's also in a way naive. It was a simpler time without the ubiquitous panopticon of the modern world, without the security threats which arguably shape the modern internet and our view of it. For instance, a while back now, a couple of years I think, a luxury hotel chain in Vietnam left their customer database exposed to the internet without any password at all. Data included booking status, flight information, name, age, gender, phone number, email address, and credit card information for all of their customers. The database was hosted in the same machine as their chain's website. After being notified, it took the company 2 weeks to password protect the database. And what should be considered a complete compromise of network integrity, New York Stewart International Airport was found exposing 760 gigabytes of backup data to the public internet. No password, no username, no authentication whatsoever. The leaky dataset includes everything from sensitive TSA letters of investigation to employee social security numbers, network passwords, and 107 gigabytes of email correspondence. The data was exposed to the internet for over a year. You might dismiss these leaks as irrelevant, coming from places or people that haven't done it right. And I'll admit they really didn't do it right. But we all know that isn't it. Right now, a week can't pass when some sort of breach or leak happens. And it's not as if these leaks are happening from companies that shouldn't know better or obviously going to cut corners. Everyone has heard of and stands being a good chance of being in the 2017 Equifax breach. Millions of driving license numbers, phone numbers, email addresses were exposed with names, dates of birth, and social security numbers. 143 million people in the US were affected. And later it turned out 15 million people in the UK, including me. Yay. Even if you avoided that one, and I guarantee you're in the Marriott Starwood breach that came to light last year, 500 million people. Name, gender, address, phone number, email, passport number, date of birth, and their arrival and departure information from Starwood hotels. These are not small companies. They have full-blown data architecture teams, DevOps teams, rules, procedures, plans in place to stop this sort of thing. Neither Equifax or Marriott are startups throwing things in an AWS instance and crossing their fingers and hoping to fix everything once their Series A comes in, or they have the headcount to do it. And if they're not doing it right, are you? Just yesterday, news that Citicorp has been breached come to light. Who knows who Citicorp is? Yeah, if you've never worked for a Fortune 500 company, you've never heard of them. Citicorp provides internet infrastructure and supplies services. And reported 500 gigabytes of information has now been leaked onto the dark web from companies including Ericsson, Toshiba, Unicredit, British Telecom, Hugo Boss, Oracle, Airbus, Porsche, Volkswagen. And it's now all just out there, sitting. And the data leaks aren't really all that hard to find anymore. You just have to poke around for open Amazon S3 buckets. There's scripts on GitHub that will find these things for you now. 200 million Chinese CVs exploded on a cloud server in January, close on the heels of another 5 million Chinese rail travelers that was also in just an open Amazon S3 bucket. The existence of I've been pawned is not a good thing. Instead, it's an indicator of the dumpster fire burning steadily in the background. But it's not just big data, it's small data. Again, back in 2011, which in hindsight turned out to be a rather pivotal year, there was this. It was one of the first big mobile privacy scandals, possibly the first. Even got a name, the press called it Location Gate, and it was sort of my fault. It was quickly followed by at least 4 class action lawsuits that I know about in countries from Canada to Taiwan, a US Senate hearing, and an operating system release to patch the problem. I got a phone call from Steve Jobs. I didn't enjoy that. 8 years on, I still get email about it. And it was just a bug in the iPhone operating system, a cache file that wasn't being swept like it was supposed to be. A bug allowed data to build up, generating a record of everywhere you'd been, every cell tower you'd passed since you first started using that particular version of the operating system. It even persisted across phones. If you changed your phone and restored your backup from your previous iPhone, it came with it. Everyone with an iPhone had almost a year of data built up on their phone by that point. This is my movements around the southeast and southwest of England around that time. And 8 years on, we're no further forward. If anything, we are now worse off. These days, LocationGate wouldn't even be a story, let alone worldwide news. I'm not even sure I'd write it up on my blog. This is something that broke last year, but it's actually still ongoing. It turns out that not only are cellular carriers sharing our location with third parties, some of the people they're selling it to, the data aggregators, are taking such poor care of the data that you can track anyone's location in real time. One site had a try before you buy page that let you test the accuracy of the company's data set. While the page theoretically required authorization, explicit consent from a user before location data was revealed through a one-time text message, the phone you were asking about, the website had a bug that allowed you to track anyone else's location absolutely silently, without their permission, in real time. The bug, in fact, may well have exposed nearly every cell phone in the continental United States and in Canada, that's over 200 million people, by the way, to having their location tracked silently and continuously in real time for months, if not years. 8 years between a data leak that was so egregious it made worldwide news and caused the US Senate hearing, and now our industry is uploading the same data into the cloud and exposing it through an API that, due to sloppy security, means that just about everyone can be tracked in real time. That's not better. And soon, every piece of clothing you wear, everything you carry with you will be measuring, calculating, and weighing your life. It won't just be your phone, it will be every car you ride in, every lamppost you pass in the street. It will all be collecting data. I'm starting to think we shouldn't be uploading all this to the cloud at all. This is an amazing and actually quite intriguing data set that was obtained using a Freedom of Information Act request to the New York City Taxi and Limousine Commission. I don't know if any of you have seen it before. It's every taxi trip in New York between January 2009 through to the middle of 2017. Data includes pickups and drop-offs, locations, trip distance, itemized fare, passenger counts, and even how the passenger paid. It's really quite a cool data set, but it wasn't anonymized properly. The personal identifiable information, the driver's license number and taxi number, wasn't anonymized properly, which means you can tell which driver drove which trip. Worse yet, at least from most people's point of view, passenger identities can be de-anonymized through GPS and harvesting. It's always hard, but I would argue that it's impossible to properly anonymize a data set of this size when it has any sort of location and data in it at all. This data set means you can track celebrities and find out how they tip. However, even if you ignore the poorly put upon celebrities, multiple pickups at a commonly frequented location, a public building, a bar, your place of work, with drop-offs clustering at another location, say your home address, lets you find more regular people and identify them as patrons or customers of, say, certain establishments. The last decade can be summed up with this question. You're being watched. Are you okay with that? And our response, which is this: we haven't realistically given anyone a choice. As our new tools, those new levers in the world, came into widespread use, over the last decade, we've seen an increasing aggressive, rapid erosion of our privacy. Because the privacy really isn't about keeping things private, it's about choice. The choice of what you tell people about yourself. In a way, the GDPR is our own fault as an industry. A reaction to egregious fashion as we as an industry handled the introduction of the previous cookie law. The ubiquitous, this site uses cookies, banner that runs atop most websites these days may meet the letter of the law, but it violates the spirit, and it really, really annoyed the European Union. That wasn't what they thought was going to happen. And of course, we're doing it again. Technological fix rather than a cultural one. This is not in the spirit of the GDPR. I'm not even entirely sure it's inside the letter of the GDPR. And anyone that tells you it is lying to you because no one really knows yet. And this is arguably worse. You go to a website and all you see is a big click-through with an OK button and various very hidden links to try and manage your own privacy. The ironic thing here is opting out of cookies adds yet more cookies to your browser. That's what ironic means, right? GDPR compliance industry is snake oil. And to be clear, to imply someone is hawking snake oil is not only to call their product low-quality garbage, it implies that they are knowingly defrauding customers to sell them junk. Fight me later. Because the GDPR is actually pretty simple if you want to abide by the spirit of the law rather than trying to find technological or legal loopholes around or through it. The GDPR gives people rights that as an industry we are ignoring. The right to view your data. You should be able to access your own personal data for free. To be informed, you should know and understand what happens to your data and why. To be forgotten without compelling reason. And that would be a compelling reason to the user, not to you as someone taking the data. You should not keep their data, and the organization should delete it. The right to move your data. You can obtain and reuse your personal data with other services and providers. The right to say no. You can stop direct marketing and data processing where there is no compelling reason, and that's compelling reason to you, the user, not the organization that holds the data, that there is no compelling reason to do it. The right to limit how your data is used. You can block and put restrictions on how your data is used if it's inaccurate or unnecessary. The right to make changes to your data. You can update any data that's out of date or false. The right for human-made decision-making. Users can stop automated decisions being made about them if it has a legal or significant consequence. And that's an intriguing one, and no one really knows how that's going to go yet. This is a solution a lot of American sites decided to use. That's not going to work much longer for them because California just passed the CPPA, which is tackling the exact same problems as the GDPR. The clock is ticking on if your company is doing this. And really, the GDPR represents the absolute minimum level of respect you should show other human beings. And if you have problems fitting your company's use of data inside the GDPR, you have a problem, not the rest of the world. You are the dumpster fire. This, for instance, this is an actual screenshot from an actual app controlling actual smart light bulbs. Just like some US-based sites, this particular light bulb stopped their service when GDPR came into force. You can still turn individual light bulbs on and off one at a time, but everything else gets taken away if you tell the app you refuse their new privacy policy. Which makes you wonder what data about when and what bulbs you're turning off this company is actually going and selling behind the scenes, or using in ways you don't expect. To be clear, I'm not entirely sure this response is legal under the GDPR. You can't refuse to provide service just because the user refuses to let you have data, unless the data is required to provide the service. Does anyone want to guess what GDPR infringing personal private information is necessary to turn light bulbs on and off? Anyone? I can't think of anything. Which brings us to now and next. The next internet, the one made of things. And here we have a chance to start again, but we haven't really done it very well yet. We're not off to a good start. A couple of years ago, it was discovered the company behind Cloud Pets, essentially an internet-connected teddy bear, left their database exposed public to the internet without so much as a password to protect it. That seems oddly familiar. The database referenced 2.2 million voice recordings of parents and their children. And with those references, you could retrieve the actual recordings of the voices from the open Amazon S3 buckets. The person that discovered this problem tried to contact Cloud Pets for about 3 weeks and was unable to get any response from the company at all. Then this database was subject to a ransomware attack and was deleted, which was the only reason it got taken off the internet. Exposed services, misconfigured services fall out from our industry for the most part, and now so common there's even a search engine for this stuff. This was a search I did for a specific version of a web camera I did this morning that I know being particularly vulnerable. There are feeds from shops, offices, storage rooms, gardens. It's just there, sitting there, waiting for you. The data generated by things, by network-connected smart things, is almost invariably sent to the cloud, where it's carefully aggregated, packaged, and sold. And this model is being forced on companies because of the other internet, has made most consumers unwilling to subscribe to services. And while we might be willing to pay for the device itself, the physical thing we can hold in our hands, we expect software and services to be free. That's a bit of a problem. Because suddenly it's not just our email or photographs of our cat, but our location to the centimeter, our heart rate, our respiration rate, not just how we slept the night before, but with whom. The privacy and attention we're trading for our free services and content is much more personal. A few years ago, iRobot, the company that makes the adorable robotic vacuum cleaner called the Roomba, gave it the ability to map your home while keeping track of its own location within it. Then we found out they were preparing to sell those maps, share those maps with their commercial partners. You did give them permission to do this because you ticked the yes box on their terms and conditions. You read that, right? No, I didn't. Turns out people weren't quite as sure that trading this sort of data for services was such a good deal anymore. Unfortunately, it's not just the data of our smart devices that creates a problem. The metadata, the web traffic generated by those things installed in your homes, can reveal a lot of information about your habits and lifestyle. Just looking at the traffic flow between your Internet of Things devices and the cloud services shows emerging patterns. This is a really interesting piece of work by Adam Sandler, more than a few years ago now. He was at the University of Rochester at the time. I think he's at Google now. Anyway, he looked at Twitter users who routinely tag tweets in their location, with their location. He didn't care about the actual data of the tweets, just the metadata, the location. He found that a couple of weeks of location data on an individual combined with the location data of two of their most sharing friends was enough to place that person within a 100-meter radius, 77% accuracy. That rises to nearly 85% accuracy when you combine the information from 9 friends. Even someone that had never shared their location on Twitter at all could be pinpointed with about 50% accuracy from information available from 2 friends and about 60% accuracy from 9. You can find people who don't share their location just by finding out where their friends are. This was from last year. If you thought the Stratover's heat map fitness data was properly anonymized, no, think again. By manipulating the API, it was possible to de-anonymize the company's data release and show exactly who was exercising inside the walls of some of the world's most top secret facilities. Making a data request for a specific geographic location, for instance, a nuclear weapons facility, it's possible to view the names, running speeds, running routes, and the heart rates of anyone that shared fitness data within that area. A couple of black sites in Iraq and the Middle East were uncovered through this route. There's a real problem in data ownership. As customers, we may have purchased a thing, but the software and services that make the thing smart and the data that it generates all belong to the company. Last year, for instance, John Deere told farmers that they don't really own their own tractors, just the licenses to the software that makes them turn on. It means that not only can they not fix their own farm equipment, they can't even take it to an independent repair shop, which changes the very idea of what it means to own something. For instance, recently, as Hurricane Irma bore down in Florida, Tesla issued an over-the-air software fix for their cheaper car models in Florida, temporarily giving owners an extra 30 or 40 miles range. The cheaper models had been software locked to use only 80% of the available power in the batteries. The remaining capacity would normally have been unlocked only by paying extra. Nobody trusts us anymore. Nobody trusts our industry. Uber, for instance, decided to reverse its controversial move to track users even after their trip had ended, saying they hadn't properly clarified what value consumers would gain. probably because the consumers wouldn't have gained anything. We need to sit back and think about why we're doing what we're doing, what the big data industry is for, rather than just using the tools that came along back in 2011. We need to look around at the new tools that have become available since then. Because in the end, we never really wanted the data. It wasn't the industry is not about the data. It's about the insights and actions that the data can generate that add value to everyone, both the consumers and the companies. Insights into our environment are more useful than write-only data collected and stored for a rainy day in a big lake. Which makes me think about something Alistair Crowell said right at the back of this roller coaster side. Big data isn't big, it's the interaction of small data with big systems. It might be time to disassemble the big systems we've spent 10 years building, because I'm not sure we need them anymore. I'm not sure we need the cloud anymore, at least not everywhere. Now, for anyone that's been around for a while, this isn't going to be a surprise, as throughout the history of the industry, depending on our state of technology, we seem to oscillate between thick and thin client architectures. Either a bulk of our computing power is hidden away in distant servers and racks, or alternatively some massive distributed systems much closer to home. We're on the swing back, away from large-scale systems, which is where this comes in. This is a leading indicator. This is the Coral dev board from Google. Underneath the heatsink is something called an edge TPU. It's a tidal wave of custom ASIC that we've been released to market over just the last few months, really. Intended to speed up machine learning inferencing at the edge. No cloud needed, no network needed. Take the data, act in the data, throw the data away. And by speed up, I really do mean that. On the left, we have the MobileNet SSD model running on an edge TPU. On the right, we have the same model running on the CPU of the dev board. The CPU is a quad-core ARM Cortex-A53, if that means anything to anyone. The difference is dramatic. Inferencing around 75 frames per second on the edge TPU, the custom ASIC, and 2 frames per second on the CPU of the board itself. No cloud needed, no networking needed. And by tidal wave, I mean exactly that. This is only part of the collection sitting on the lab bench back in my office right now. On the market, we have hardware from Google, Intel, NVIDIA, hardware from smaller, less known companies coming soon or already in production. Some of it designed to accelerate existing embedded hardware, like those USB sticks attached to the Raspberry Pis here on the bench. Some of it designed for evaluation boards for system-on-module units that are going to be made available in volume probably towards the end of this year, like the Coral dev board or NVIDIA's Jetson Nano, which you can see in the middle there. Here's what the system-on-module beneath that Coral dev board looks like, hidden beneath the heat sink. No price point yet, but the pricing on the eval boards, I'm expecting it to be reasonably competitive. I'm not going to go too much detail here, as I haven't cleared this entirely for release, but hopefully by the time the video comes out, I'll have all the bits of paper in place. Look out for Twitter on this sort of next week, I think. This is a sneak peek at some benchmarking results that I'll be releasing next week. This is milliseconds per inference for MobileNet V1 and MobileNet V2 SSD models for various bits of hardware. We can see the Coral dev board here, the NVIDIA Jetson with the optimized version here, the Intel hardware here, and my MacBook for reference and a Raspberry Pi at the end, just for amusement value, really. Equally crucial for edge computing, this is the idle and peak current in milliamps for the platforms. Again, not much detail here. Check back on Twitter with me next week, anticipating probably Tuesday. And of course, custom async we're seeing over the last year or so, the last few months, is actually at the high end of the embedded hardware stack. This is a board based around the SciPed AI module. It's built around something called a Kendryke K210 processor. It's got two 64-bit RISC-V CPU cores, each with an FPU, but it's also got a neural network processor called a KPU for supporting machine vision applications. It should handle about 60 FPS at QVGA and about 30 FPS at VGA. There's also an audio processor if you want to hook this up to a far-field microphone array. These tiny microcontrollers don't have enough power on them to train neural networks. We blatantly need the cloud for that. However, we can run inferencing on using existing models, existing TensorFlow models, using embedded C++ versions that are generated using tricks like quantization. This is one I've had a little bit of a hand in. It's the SparkFun Edge board. It's based around the ultra-low-powered Ambic Micro Apollo 3 processor. That's an ARM Cortex M4F running at 48 megahertz, if that means anything to anyone. It's an insanely low-powered piece of hardware. It consumes 0.3 milliamps running flat out and 1 microamp in deep sleep mode with Bluetooth turned off. That's pretty much the power budget for this. Running full tilt is less than most microcontrollers draw when deeply asleep waiting for something to wake them up. If you remember the chart I showed you a couple of seconds ago, the Raspberry Pi consumes around 400 milliamps idle. This consumes 0.3 milliamps. And it runs TensorFlow Lite. And there should be sound for this, which doesn't happen.
Yes.
There we go. Okay. Let's do that again.
Yes.
Just keep your eye on lead 47 there.
No. Yes.
Real-time machine learning on a microcontroller board powered by a single coin cell battery that should last for months, even years. No cloud needed, no network needed, no private personal information leaves the board. At least in the open market right now, this is machine learning at the absolute limit of what our current hardware is capable of. It doesn't get any less powerful than this. The arrival of hardware designed to run machine learning models at a vastly increased speed and inside relatively low power envelopes without needing a connection to the cloud makes edge-based computing an attractive proposition. And with the release of TensorFlow Lite 2, as well as TensorFlow Lite for microcontrollers, the ecosystem around edge computing is starting to feel more mature, which actually means the biggest growth area is for machine learning practitioners over the next year or two could well be around inferencing rather than training, which is sort of interesting. If you go to the web and search for how do I do stuff, there are hundreds, thousands of tutorials on how to train models, and very, very few on how to optimize them for inferencing on hardware. Because we're used to running these models on hardware that has all of the resources that we need. Putting them on the edge means that over the next year or two, you should be thinking about that. Especially when you're thinking about inputs. Right now, the best sensor we have is the camera. And a lot of our machine learning models are optimized to use that, are designed for it. But on the edge, there are other things. New materials that our future technology will become much more invisible. This is a key mode made from ferroelectrite nanogenerator, or FENG, a paper-thin flexible material able to harvest energy from motion. Compressing it produces electrical energy. It's sensitive enough that even sound waves produce small amounts of electrical energy, can be used as a microphone, in other words. The material is equally effective in reverse, converting electrical energy back to sound. This could eventually lead to foldable loudspeakers, stick-on microphones, talking newspapers, all powered by vibration. The technology itself is invisible, however, and the data it collects will equally be invisible. This plastic brain, you always have to have a plastic brain in a talk, is covered in spray paint that turns anything you paint into a sensor. When someone touches the paint, the finger shunts a tiny amount of current to the ground, affecting the current flow. The change in current can be detected, and the finger position can be sensed within a centimeter or so via a technique called electric field tomography. Along similar lines, this is a project called Zensai. It uses biosensors, advanced signal processing, and of course machine learning to identify people solely on their body's electrical properties. Yes, this is real. This is not an April Fool's joke. It even works through clothing. In other words, using this technology, the objects around you can figure out who you are without you having to wear, carry a token, or be wired up in any way. If you were in Morris and Paris' talk yesterday on user influences from sci-fi, this is the start of contextual computing in the real world. This is the world figuring out who you are without you having to tell it. We're right at the start of a shift in the way we collect data and the amount of data collected. Over the next 2 to 3 years, there will be a massive ramp in the amount of data available. And I don't think we should put it in the cloud. I really don't. We haven't done it well so far. Why would that change? One more thing then. Earlier this week, on Tuesday, Zuckerberg stood up on the stage at Facebook F8 conference and said, "The future is private." Even if you don't believe him, and quite frankly, why should you? The idea that this man, the man that 10 years ago stood up and sold us on the mantra of the big data age, that privacy was no longer a social norm, said this, tells us something. It tells us that that age is over. If we can give our users, our customers, our friends the choice not to share their data with us and yet still give ourselves the ability to obtain and act on insights into their behavior, to customize the world to them, that's not a bad thing because we don't need the data to do it anymore. Or at least we don't need to keep it. Moving what we can to the edge might not solve everything. It won't stop those awful data leaks entirely, but it's going to be a good start. Take the data, act on the data, but then throw it away, please. Thank you. Yeah. So to repeat that, while you can do real-time inferencing in the real world in deployment without having the private data go up into the cloud to actually do training, there still has to be a large data set to do training. Yes, that is problematic. But if you have a large data set, if you've gathered a large data set to do a specific training job, then you can be far more systematic about privacy. You can be far more systematic about obtaining permission from users to go into that training data set. In the past, we've been really bad at that as well. Don't get me wrong. There was a recent case where academics harvested all the Flickr images of people's headshots. Anything that was Creative Commons, they just went and ripped from Flickr and trained some machine learning models from it, which is entirely legal because it was Creative Commons. You could reuse it for purposes, and it was on the web, and it was fine. But when people found out it was being used in that way, they were really upset. There was a flurry of newspaper articles about it. You might not have seen them. So yes, training data is a problem. I think companies will have to become more careful about how they get their training data sets. And yeah, I agree, those data sets are the secret sauce of the entire machine learning revolution. But yeah, it's a problem. I think you were first.
So I was slightly more optimistic about training through distributed machine learning. I've seen material where that is possible. It does require more power towards the edge in those things, but I think with the examples you gave around the generation of electricity and those things, it's more options are available. I was wondering if you had an opinion on the idea of simulated data training, because the data is not real, it's entirely simulated, and whether you had any thoughts there.
It's not something I've had particularly good results with. I have attempted small-scale experiments around simulated data, but most of my use cases for machine learning is for objects in context. So simulated data does poorly. It might be interesting to do sort of like a full Unity 3D build of a situation and try and put a simulated object in context and try and train on that and see how well it would work. My normal reaction is that computers taught or expecting simulated data do poorly when presented with the real world that has problems. You know, rain, fog, darkness, things like that. So yeah, it's certainly one possibility, but I don't know. It's not. I don't think there's much work on it yet.
Yeah, really thought provoking talk. I think really for me what comes out is that people don't feel the pain if you do it poorly. They're not feeling enough pain from doing that today. Obviously, Facebook seems to be a good example where they maybe making that change, and they've probably felt some pain. I'm interested. What we see 7 devices in the home today. 2025 we're talking about 70, and there seems to be a need to connect that up to simplify people's experience and do it the right way. How do you see that? The idea of it not being connected just seems to be a missed opportunity for humanity if you do it well. Have you thought that?
Yeah, I mean, I actually had a startup on this like some years ago before IoT was profitable enough to actually have a startup on it. So that was a bad idea. So yeah, my own attitude to this is that many IoT devices right now go up into the cloud. So for instance, I have IoT thermostat in my home and a number of IoT temperature sensors around, and also carbon dioxide sensors. So my thermostat is entirely possible to turn air circulation on around my home if the CO2 peaks in a room. Because like we've been sitting there for a long time, watching like the Game of Thrones marathon or whatever it is we're doing, and the CO2 in that room is high, so you want your thermostat to turn on air circulation to like lower the CO2 levels. To do that, first of all, the two things don't talk to each other at all, but that's another problem. But to do that, you'd actually have to send data into the cloud from one of them, and then the other one, which is in line of sight to the thing that measures the CO2, would have to go up into the cloud and get that and come back, and that seems awfully dumb. It's like, what happens if my broadband goes out? I can't turn my heating on and off. What happens if my my broadband goes out? I can't turn my lights on and off. It seems odd. So yes, while you don't necessarily want to take the network connection at all, I think for consumer adoption of IoT devices, you're going to have to move far more to local control. So they're going to have to be addressable and controllable and manageable on the local network rather than using a cloud backend. And that's going to, there's whole levels of standardization. I have all other talks on this, like the IoT talks I've given before at Strata and AIConf and various other O'Reilly places. It's an insanely hard problem that's not really been done well yet.
One question. It's obvious what motivations would be for, say, NVIDIA or Intel to be doing low-power edge devices.
Yep.
How about Google putting...
Interesting, isn't it?
Is there any sort of stated rhetorical posture of why?
Yeah, but it's Google, so I'm not entirely sure I understand it, right? There has been stated postures from Google about why they're doing. It's a sort of cross-company initiative for cloud from the, machine learning from the edge to the cloud. It's like, there's also a cloud TPU that you can use to train using their cloud services. So you can use your training there, and then there's theoretically, I'm told, sort of hooks between this edge TPU inferencing and the cloud TPU training is going to be all put in place. So it all hooks up. It all is all a seamless product that you can use. But Google changes its mind every 5 minutes, so I don't know. It's interesting to see them do it, and interesting to see others, notable others, not.
So when you talk about how you should use the data and throw it away, that was always kind of the drive behind the most fundamental definition of stream processing, where you used to have input model, output, and input output.
Yep.
processing on there?
Yeah. Yeah.
Why aren't they targeting that if that is the
I
further extension?
We're on really early days, I think. I think people are still feeling around for what you can do. But yeah, I absolutely agree. You can do stream processing. It should be entirely possible.
With those devices, typically, do they even have an operating system?
Some yes, some no. So the Curl dev board, for instance, runs a version of Debian Linux. NVIDIA's runs their, I can never remember the acronym, it's basically their version of Ubuntu, which has got a whole bunch of CUDA stuff pre-installed. The Intel hardware is mostly, like the stuff that people are using is mostly the USB stick, so it just plugs into a Linux machine. The really low-powered stuff like the SparkFun Edge board, of course, has no operating system. That's bare metal. There's a bunch of bare metal options. Mostly it's C++ right now. The K210 stuff, the SciPed stuff I pointed out, that's really interesting. It's right on the borderline between the two. It actually has enough RAM and processing power to run an operating system, and you can do it using TensorFlow Lite in Python on it, just about. Or you can just flip and use C++ and program it bare metal. It's an interesting chip that's only really sort of starting to make its way into the West now. I think it's been kicking around in China for a little bit. One last question. Okay.
Yeah. I've been thinking, because you also referenced Alan Kay. Oh, you didn't, but anyways,
I did.
a big fan. That was Alan Kay?
Yeah.
Okay, because I thought it was the author of the mother of all demos.
No, it was the quote part was Alan Kay, but yeah.
Okay. Anyways, his view on how to change our behavior is not by regulation, but by education.
Yeah.
And I really believe, and I wonder what your thoughts are about this, but like what Raspberry Pi is doing, what all the other small systems are doing, is they want to educate people and show them that you don't actually need to send the data to the cloud.
Yeah, I mean, I think in education is a huge part of it. It has not been successful so far.
No.
Which is why there is a GDPR, which is why there is the California Act coming in. The governments had given us a great amount of rope to hang ourselves by, and we tied the knots and stepped onto the noose. And that's our own fault.
Yes.
So, yes, I would love to think education could fix it, but it hasn't so far. More education needed.
Yes. Yeah.
Thank you.